Brilliant. Good morning, everybody. Thank you for waiting. We're just setting up and making sure all the presentations were working this morning. Welcome to this year's PDM paper presentation competition 2021, where we're pleased to announce we're going to be holding the regional finals for this year. Just a quick introduction to myself. My name is Kyle Ingram. I'm the Head of Operational Excellence at Cadent and the Chair of the Professional Development Network, also known as the PDM. I'm really excited this year to announce we've got a packed agenda with 5 brilliant presentations to be presenting to you. We'll start off with a brief introduction, housekeeping this competition overview before going into those presentations. Just before we then head off for a judges discussion and break, where following that shortly we'll be announcing the winner of the competition today. So firstly, thank you all for joining us. Just a couple of general housekeeping reminders. We are obviously recording this session. So I ask, please, can you turn off your camera and also mute your mics like everybody is already. Thank you. So just to give you a quick overview of the challenge and what all our finalists have gone through already so far. Each of our finalists today has already submitted 250 word synopsis at a regional level. Related to the pipeline industry. They were shortlisted into their regional finals and invited to give a 15-minute presentation on their synopsis to an audience and panel of judges from the regional branch. And the winner was then asked to represent that region at the Guild final. Today is a lot more strict. All finalists today will be asked to present their selected topics whilst keeping their presentations to a 5-minute limit. As well as followed by 5 minutes of questions from our judges. On top of that, each entrant is asked to keep all their content to a maximum of 1 slide. The winner today will receive the £500 prize, as well as being champion of 2021. But also just want to highlight that every finalist today has also been invited to attend our annual Guild dinner on the 8th of March next year. Lastly, one of the rules that was on entry is all our entrants today are 35 years of age or younger. So just to introduce our lovely judges today, Kate Lazenby will want to be our judges, our Executive Director of the Pipeline Industries Guild. I'm also pleased to announce John Murphy, our Guild President, will be one of our judges today, who is the CEO of the Murphy Group. And lastly, Dan Jefferson, our Guild Chair and our Engineering Manager at JM Bentley. We are 3 judges presenting they're judging for our 5 finalists. What they will be looking at today is 2 main focuses of areas around the quality of the content and quality of delivery. They all have received the original synopsises of the 5 finalists, but then what we'll also be looking at is the originality of the content, relevance of the material, quality of the presentations today, and their ability to answer the questions. Of course, as mentioned earlier, that there will also be a 5-minute timing area as well. So last but not least, introducing our 5 finalists. I'm really pleased to announce that we'll have Serena Veriah from Severn, Trent, our Midlands regional winner, who will be presenting on the hidden treasures of the water network. Megan Macpherson from Atkins, our Wales and West regional winner, who will be presenting on Medina and Tabak Master Plan. Michael Sinclair from Cadent Gas, our Northern regional winner, who will be presenting on hydrogen-powered construction site trial. Daniel Mee, also from Cadent Gas, who will be our Scottish regional winner, who will be presenting on reduced depth of cover gas distribution assets. And lastly, Natalie Lamb, our South East regional winner from QCL, who will be presenting to us on experimental pipe facilities and investigation of chemical-free water. So they are our 5 finalists, and I can now ask Serena to present on her 5 minutes slide if possible.
Hello, yeah, I'm just going to start my screen share.
Thank you, Serena.
And can you all see that?
Yes.
Cool. So hello, I'm Serena Veriah, and today I'm going to be sharing with you the secrets to the water industry's best hidden treasures. I joined Severn Trent Water in 2018 as an apprentice project manager, And then in April 2020, I moved into a team which has the objective to inspect, clean, repair, and re-enter into service hundreds of DSRs across the Severn Trent region. What are DSRs, you may ask? They are distribution service reservoirs, and they have the essential job of providing all of your houses with clean drinking water every single day. There are over 400 DSRs in the Severn Trent region, and they're basically these huge tanks which hold clean drinking water after it's left the water treatment works, and then distribute it into the pipe network when there is demand. I'm not an engineer, so I'm not going to go in depth about their build and their structure, but what I can tell you is that they're essential and magnificent and walk past every single day with most people not even knowing they exist. I certainly didn't before I moved into this team. In order to inspect these DSRs, I had to be confined space trained. And here you can see me standing on top of the first ever DSR I inspected. Most DSRs are concrete built, like this one here, but the most stunning ones are the brick built ones. The oldest DSR that I've ever inspected was built by the Victorians in 1851, making it 170 years old, and that's Bellevue DSR in Nottingham, and that's the oldest DSR in the Severn Trent region. To put that into perspective, that was before the Crimean War and before even the first women were given the right to vote in the UK. So it's a real part of history. Unfortunately, it's been recently discovered that the DSR is no longer structurally sound, so that any work that we did want to do to the tank could no longer go ahead because it could actually damage the tank further. So it's a real shame because it was providing water to over 37,000 properties every single day. But all is not lost. I'm currently working on another brick DSR project in Leicester, which is New Parks, you can see here. It's got lovely brick, red bricks and lovely sweeping arches. It's built in the same way that Bellevue was. This is the second oldest DSR in the Severn Trent region. It was built in 1853. So hopefully work goes well on that and we can start work on site in the new years, fingers crossed, all going well. Today, I'm going to use this presentation to honour Bellevue DSR now that it is out of service, which is a shame, but it has such an interesting and exciting history, which is not widely known at all. So I thought I'd share that with you today and maybe we can all learn something new. And I'm going to start by talking about an engineer who was instrumental in building and designing the DSR, and that is Thomas Horsley. He was born in Nottingham, and in 1830, he started working for the Nottingham Water Works Company, and he was instrumental in the design of DSRs, but not only that, he was instrumental in making Nottingham the first city in the UK to have a constant water pressurised system, which led to a reduction in diseases that were rampant in the time in water, like cholera. So he was a real innovator for his time. Here are some pictures of the beautiful Bellevue DSR. The photos never ever do it justice, but you can get a little grasp of what it's like inside with the lovely stone steps and the beautiful brick archways and little section it's all split into. And it's crazy to think that was 170 years ago that was done. I actually managed to find some articles by the Nottinghamshire Guardian and the Nottingham Review from when Horsley actually worked on Bellevue DSR. So I'm going to transport you back in time now to 1851, where you can imagine that you're there for the construction of Bellevue. So a little snippet from the article here. All the important townsmen gathered on the roof of Bellevue DSR, which is exactly where I took this photo here in number 7. And then they entered the lit up tank. It didn't have water in it at this point. And they sang the national anthem, Rule Britannia, and they had refreshments and drinks. And that when the first drops of water actually entered the tank, they all rushed to try and be the first one to have a taste of it. And then after, they went into the city centre of Nottingham to go to a local inn where they made a toast to Thomas Horsley and to Queen and Country. What an amazing little snippet of history right there, just so those articles for this tank. And I can't help but think about that when I'm doing my day-to-day work and what an amazing job these engineers have done. Some of these tanks to still be functioning today, which is obviously amazing. They really should be preserved. And I feel incredibly lucky and honoured to be one of the few people who get to go and inspect these tanks and help manage the repair works of these tanks. And I really wanted to share that with you today, and hopefully they can be preserved for future. And yeah, I just wanted to give you a short history lesson, and maybe you can learn something new. And maybe when you're out and about and you spot a big semi-submerged structure like in photo 8 here, you can actually stop for a moment and think and think about the people who have built it in the past, and past generations of your family may have had that water, and even your future children and grandchildren to come. And then maybe in the future we can find ourselves having DSR museums in the same way that we've got pumping stations being preserved. Thank you very much. I hope you've enjoyed it and learned something new, and I look forward to any questions that you may have.
That's brilliant. Thank you very much, Serena. No, it's a really interesting bit, and I'm very impressed you got some articles back to 1851 as well.
Yeah, I had to do a little bit of digging, but yeah, there's some interesting stuff.
That's great. And what I'll do, I'd just like to invite Kate, John and Dan to join us on camera and off mute as well, please. So we can start your 5 minutes of questions, please.
Okay, I'll jump in there first. So Serena, that was an excellent presentation, and yeah, very, very interesting. And yeah, I'll definitely be looking out when I'm out and about. So you're very passionate, clearly, about the topic. So what's sort of been the biggest challenge you've overcome, perhaps from a personal perspective, with regards to sort of the work you've been undertaking with the inspections, and how have you overcome that?
I think maybe when I first joined the team and getting confined space trained to actually be able to go in and inspect these tanks. I've never had to do anything like that before, and it was done by the Mines Rescue Service, and they had to teach you how to use your breathing apparatus and put your harness on, stuff like that. And when I entered my first tank, I was so nervous at the thought of, oh my god, what could go wrong, especially when you're equipped like a gas monitor on you. I was like, is it often, am I going to have to escape, am I going to have to use my breathing apparatus and escape? But everything's been all good so far, but that was definitely a challenge at the beginning, getting into these tanks. And they're not always easy to access as well, whether in the middle of the countryside, some are in the middle of the city centre like that one, but some are out in the sticks, and then entering the tank down some old ladder. And the one in Bellevue was a set of stairs that go down, and you had to be all harnessed up. So that was definitely a challenge with my personal journey in inspecting these tanks. Was yeah, getting used to doing something that's so different to day-to-day work, I guess.
Thank you.
John?
I think I suppose one question for me is, obviously you're inspecting an array of these structures, all with different age profiles. I suppose, you know, from a engineering and construction perspective, you know, I suppose, what have you learned from how Victorians delivered and built these structures, and how does that sort of tie back into construction today?
Well, the way they built it is, like I said, with bricks. Now it's done with concrete, and the bricks aren't actually as waterproof as what we need them to be. So it's a good thing we're using concrete now, and that's what we're using for our rebuilds. However, I understand there's a big environmental impact of using concrete for our designs. Hopefully that's something that we can consider going forward with how we're supposed to be rebuilding some of these tanks. But thinking back to how they did it, obviously that's the materials they had at the time, and maybe brick wasn't the best option, we wouldn't use it now, but maybe concrete's not the best option either. So I think a lot more thought needs to go into the future of building these tanks, because the brick ones aren't going to last forever, and new ones are going to have to be built soon. Like in the presentation, Bellevue's coming out of service now, and something else has to pick up the slack for the water that it's going to be no longer providing. And maybe concrete's not the best option, but I guess only time can tell with the new materials and new work and research that's going into it.
Thanks, Serena.
And Dan?
Yeah, thanks, Serena. It was a really interesting presentation, and nice to get an insight to the past, as you say. Yeah, you touched on a little bit around the sort of Victorian time, and talked about the Thomas Horsley in particular. Is that now a sort of area of interest for yourself? Are you doing any other research or fact finding on any of the other reservoirs that you're looking at?
I try to find if any were listed actually as part of my research, because there's going to be quite a few out there in the Severn Trent, not just in the Severn Trent region, but across the country. And I tried looking on the register of listed buildings to find some more history about any of them, but I couldn't find any on there. I did look and I did try and research more. I think they're not widely known about outside of the water industry and the teams that look at it. And they probably should be. I had to do quite a bit of digging to find some articles about this tank when it was built. I'm sure they're out there somewhere, and I'll continue trying to find more information about it. But whether I'm successful or not will be a different story, I'm sure.
Very good.
That's brilliant. Perhaps we've got time for just one more question. I don't know if anyone had. Kate, John, or Dan, you had one more? No, brilliant. Well, thank you very much, Serena, for a very strong first presentation. What I'd like to do is now invite Megan to present your presentation, please.
Okay, can everybody hear me?
Yes, we can.
Cool. Okay, let's hope this share screen works this time. Okay, can we all see?
Yeah, that's it.
Okay, cool. Hi, I'm Megan. I'm a graduate civil engineer working at Atkins, and I'm going to give you a quick introduction to a water and wastewater master plan project for Saudi Arabia. I've been working on this project for just over 2 years now. So just to give you a bit of background, Atkins have been tasked with covering northwestern Saudi Arabia, which is made up of 2 separate regions, Medina and Tabuk. So both regions are split down into various governorates, each with a main city and with a main city that's surrounded by various rural settlements. So the aim of this work has been to define the projects that are needed to improve the quality and the coverage of the water and wastewater infrastructure in the area. We needed to consider the needs of the population up to 2050 and also deliver all of the proposed works in that time frame as well. So rather than try and talk you through the whole process of the master plan in 5 minutes, I've just picked out a few features of the project that I've found particularly interesting or challenging. So the first is Saudi's Vision 2030. So this is a strategic framework that's aiming to improve public sector services across Saudi Arabia. And this framework presents quite specific milestones for water and wastewater services. One of these is to make sure that by 2030, 100% of people in urban areas and 95% of people in rural areas are connected to networks. So just to give an idea of the situation at the moment, approximately 20% of people are not connected to a water network and 40% of people are not connected to a wastewater network. So the target to increase the coverage so significantly by 2030 essentially condenses that planning period, because a lot of projects need to be delivered by 2030 rather than by 2050. So one of my first tasks on the project was actually linked to this target, because I needed to geographically locate loads of population that were not yet connected to a network, and it was a task that was made particularly difficult by a lack of data, but we needed to quantify how much of the population were unserved and locate those areas that were most in need. So the next challenge I've looked at is the Pilgrim Influx. So the largest city in Medina is actually the home of 2 religious festivals and draws a huge influx of pilgrims every year. The Pilgrim Influx actually doubles the population of the city in those periods, which presented quite an unusual challenge in sizing the networks, because there'll be really high demands for short periods of time, and sizing the networks based on those flows would actually just create redundancy throughout the rest of the year. So the solution has been to propose large strategic storage tanks at the outskirts of the cities to deal with the demands in those periods. So now we'll move on to how they're going to meet those demands. So Medina and Tabuk are currently highly dependent on groundwater, and that is a source that's becoming increasingly unsustainable. Now, given that surface water is not really a viable option out in Saudi, the plan is to make the move to desal as quickly as possible. And at the moment, there are already some desalination plants providing a portion of the region's demand, but those are actually due to be decommissioned by 2050. So the national water company in Saudi does already have plans to introduce new desalination plants along the coast. And it was my job to look at the supply-demand balance in each area and determine whether those proposed desalination plants would actually satisfy the demand in the areas they were supposed to be serving, and whether they would continue to do that as the population grew. So after considering all of these various targets and requirements, we came up with a suite of projects to cover them all. We've actually proposed over 1,100 projects in total, with a capital investment of over £7 billion. All of these projects vary in size, but they include all the typical elements of water and wastewater infrastructure. So this animation, if it works, should show how all of our projects have been phased up to 2050, and it should demonstrate how the majority of projects are planned pre-2030 to meet that 2030 vision. So this is just an example for clean water projects, but you can see that we have a lot of projects planned pre-2025. And if we just go up to 2030, we can see that we have quite a large increase in projects before 2030. But then after that, as we go through the final few phases, there's only a really small increase in the networks that are going to be put in. So I think that's all I really have time to squeeze in today, but I'm happy to take any questions.
That's brilliant. Thank you very much for that, Megan. Looks like a really interesting project I've been involved with. I'm looking forward to this.
Yeah, it has been.
Thank you. So again, if I could ask our judges to join us again. Real. And John, should we start with you?
Thank you. I was jotting down a question here at the moment. I think it'd be interesting for me, obviously, you know, a lot of our work is sort of UK based. So working in Saudi Arabia, obviously very different climate to where we are. So what are some of the engineering and stakeholder challenges you do have to deal with when establishing a master plan that runs in excess of nearly 30 years?
So some of the biggest challenges we've found working with our client has actually been the lack of data and the lack of quality and consistency of the data. So at the moment, each governor actually has a separate O&M team, and their systems operate quite separately in each governor. So it hasn't been a case of trying to collect all the data we need for a master plan from one sort of body. We've been having to collect data from lots of different sort of governorates and try and piece all of that together. And I found it very, very different work. I've done lots of other work with UK water companies, and I think communication with the client has also been really key in understanding exactly what they want to get out of this master plan and the scope of the project and what the boundaries of the work we're doing have been. It's been quite difficult.
Thank you.
Shall I go next, Kyle?
Yeah, I was going to say, yes, please, Dan.
No worries, no worries. Megan, excellent presentation. Thank you for that, and really nice insight to something outside of the UK. So really interesting. I suppose my question is around the sort of sustainability side of development and how the Saudis are going to adopt a more sustainable approach to their construction, or if that's actually part of their thought process. You know, desalination is quite an energy intense process, isn't it? So
yeah, so yeah, obviously the first thing to touch on is desalination. It's not very environmentally or economically sustainable. It's very expensive and energy intensive. They have actually been using groundwater for so long that the sources are so depleted that they don't really have any other option but to stop using that groundwater. There's also, I think it's less than 2% of surface water use in Saudi at the moment because it's obviously very dry. That's also not really a viable option. So the one thing I would say about the desalination plants is that because Saudi is along the coast, or the area that we're looking at is close to the coast, the transmission of the water inland is maybe not as far as it would be if you were looking at sort of transporting it to a really inland area. We're only transporting the water to areas that are already sitting along the coastline. So I think that makes it more sort of environmentally and sustainably sort of viable as an option.
Okay.
And Kate, please can we have your question, please?
Thank you, Megan. That was excellent presentation again. So just drawing on John's question, just around sort of obviously working in different sort of climate engineering sort of environment, in particular with stakeholder management. I know you've obviously sort of answered with the fact that communication is key. How have you sort of, you've obviously mentioned you've worked with some sort of UK sort of water companies as well, but how have you found in particular with the actual stakeholder client engagement, how have you found that sort of gone? What are the sort of differences, or are there any parallels, and what sort of lessons would you take from that communication with the Saudi?
So obviously one of the most difficult things is the language barrier. We do have translators that sit in on our meetings and help make sure that the client and us are understanding exactly what's going on each side. One of the differences I think between working with NWC and working with water companies in the UK is that I think the information transfer between us as Atkins and water companies in the UK flows both ways a little bit more easily, whereas we have found that with NWC, we've been having to run a lot of workshops so that we're doing a bit more of a knowledge transfer from us to them, because their water networks are obviously less mature than our networks in the UK. So we have more knowledge that we can pass to them that they don't necessarily have at the moment. So I would say the most interesting thing has been running those workshops and getting them the information that we use every day, but they don't necessarily implement at the moment.
Brilliant, thank you very much. I think we'll only have time for those 3 questions, but thank you very much, Megan, for your presentation and time this morning.
Okay, thank you. Bye.
Next, I'd like to invite Michael Sinclair, please. We'll be presenting on a hydrogen-powered construction site trial.
Thanks, Carl, and good morning, everyone. The presentation so far has been great, and good luck to everyone else. I'll just share my screen. Can you see my screen there?
Yes.
Perfect. Thank you. Yes, so good morning, everyone. Michael Sinclair, graduate chemical engineer with Cadent Gas, and today I'll be presenting on my hydrogen-powered construction site trial. So construction is not going anywhere, and it attributes roughly 10% of our CO2 emissions as a country, as the UK. Directly 10% of our CO2 emissions are associated with construction activities. And there's so much going on with construction. You've got materials, you've got heavy machinery, and as we're overpopulating, we're building more homes, we're building more houses, more buildings. We've got projects like HS2. So it's a massive barrier that needs to be overcome to meet our wider net zero goals by 2050, and obviously it's more prevalent than ever now after the outpouring from COP26. We're aware of this at Cadent as well. We recently developed our 10-point hydrogen plan. It was published 2 months ago, and the very first point within that is delivering net zero construction sites from 2023. So it's only 2 years, and that's really not a lot of time, as we know, when it comes to net zero ambitions. So we were looking at a particular site in North London as part of a wider £6 billion redevelopment. But our job as Cadent within that was to commission a new pressure reduction station in that red rectangle in the bottom right of your screen there. But what's the immediate opportunity that we saw? So whilst it's difficult to decarbonise the likes of your materials and your heavy machinery, there is an immediate opportunity to decarbonise the power that you supply to your off-grid sites. And when I say off-grid, I mean it's not feasible to install a temporary connection to the electricity grid. You have to find some way of providing your own power source on site is independent of any grid. And that's traditionally done through the form of diesel generators. You'll be familiar with these on fun fairs, or if you've visited any construction sites yourself, if you've had the pleasure. They're noisy things, they're chugging away, and they're terrible for the environment. But these provide power for all the electrical appliances on site, the likes of kettles, electric heaters, microwaves, hot water sinks, anything that's plugged in and requires power on site, it needs to come from somewhere. And the options we've considered to decarbonize this, we know we can do better and we should be doing better. Obviously, the baseline is your diesel generators I've highlighted. They're cheap, they're familiar, they're easy, but they are terrible for the environment and we should do better. A midterm solution you could point yourself towards is HVO, which is hydro-treated vegetable oil, essentially biodiesel. So it's the same product at the end, but it's come from a more renewable source in the way that crops have degraded over time and absorbed carbon dioxide as they've grown. So the net carbon dioxide emissions are lower, but you still have those emissions at the tailpipe as such, and they're still noisy. Or there's this exciting development in the form of hydrogen fuel cells. We have absolutely zero emissions from an electrochemical process, the only product being water, and they're also quiet, so that can extend your range of operating hours on site in unsociable hours. But they are expensive and they are unfamiliar. But this is the solution we opted to go with on the site. So I was project manager, tasked with leading a team of 6 graduates to try and decarbonize our welfare facilities on site. And I'm very proud to say that after 8 months of planning, we did land a hydrogen fuel cell on our targeted site in London, which powered the site for 20 weeks. And we were the first UK-based gas distribution network to implement fuel cell technology in this way. So after 8 months of planning, it was a really proud moment for me to see that land on site for the first time, not just for Cadent, but any UK GDN. And some results we got from that, over that 20 weeks alone, we supplied a base load of 35 kilowatts, and we saved around 22 tons of carbon dioxide being produced over those 20 weeks. And that's the equivalent uptake of just over 1,000 trees, to give you some perspective. So the recommendation we got from this, and the one I've given to the business, first of all, I don't think we should have been on diesel in the first place. It shouldn't be the mission to get off diesel. It should be biodiesel from the start. And then how can we do even better? You're essentially putting a different liquid into the same machine and helping the environment. But the long-term solution should be green hydrogen, as we've seen. The technology does work. It does reduce emissions. But the catch right now is it is very expensive. But we can help reduce this in the future by implementing more sustainable means, and perhaps pairing it with technology such as solar cells to really get the best out of it. I was project manager, as I said, so I was pulling together all the different stakeholders, including our supplier, reporting to above at Cadent, and then including all of our internal teams, our safety teams, our engineering teams, to ensure that we were okay from all sides and everyone was happy with it on site. I learned a lot from this, managing teams, managing stakeholders, and ensuring that everyone was happy with the project and making sure that we met all deliverables, obviously the main one being landing that fuel cell on site and saving a lot of carbon dioxide emissions. I'm really proud that at Cadent we're not just waiting for this technology to be ready on the shelf and hydrogen to just land on our lap. We're actually going out of our way to be bold and conduct some really interesting trials and put our neck on the line to help accelerate the growth of this green technology. So thanks very much for listening, and I'll hopefully take any questions now.
Thank you very much for that, Michael. Another very good presentation. I'm starting to feel sorry for our judges to have to choose a winner already. What I'll do is just like to ask Dan to ask the first question, please.
Certainly. So excellent presentation. Thank you, Michael, for that. Really interesting insight with regards to alternative fuels for construction sites. One of the things I picked up on there was the footprint needed for the hydrogen fuel cell. And do you see that as being quite a limitation with regards to its use? Often our sites are constrained by the boundary and the neighbours that are there within.
Absolutely, yeah, it's a great point, Daniel. Thanks for that. Yeah, because essentially hydrogen, it's not as energy dense in terms of volume as the likes of liquid fuels like diesel and it does take up more space. So if you have the luxury of having a site in the middle of nowhere where you have acres of space, it's perfect for that solution right now. But when you're in the city centre of London and you only have a very tight space to work in, it is an issue. And that's something that the suppliers are going to have to overcome as the technology develops. Can they make it even smaller? And can they find some way to compress the hydrogen even more so that it's not taking up this huge space on site? That's something we did learn. It was taking up more space than some things which naturally would be the largest items on site. But you're going to have to compromise. If we want to go green, we're going to have to make some other things move. It's all about asset management and making room for things. So it's a challenge we all have to overcome, and that's not just the gas industry. Obviously, it's across the pipelines. We're all doing construction activities, but if we can't just talk about going green, we have to actually do something about it. So,
brilliant. And Kate.
Thank you, Michael. Excellent presentation again. So you mentioned on your last slide about personal impact, and particularly with the sort of the management of a team. So just taking more of the sort of soft skills sort of side of things, how did you find managing a team? What were sort of any challenges with behaviours? How did you overcome those?
Yeah, it was a great question. Thanks. It was interesting because I'm a graduate myself, and I was managing a team of like-minded graduates. There were 6 of us, so I wasn't exactly above them by any means in terms of authority or role, but you still have to ensure that you earn people's respect. And the way I always try to do that is make sure that no one's working any harder than you, because then you can't ask them to do more than you if you're in that position. So I was giving it my all and making sure they all had opportunities to give a lot as well, and they did. And it was quite tough over such a long project, in the way that it was 8 months of planning for only essentially 3 to 4 months of being on site. So at times it would feel like it was dragging on a bit, and it almost got frustrating, but it was definitely worth it for all of us. It was really rewarding to go out there and visit the fuel cell together and see the fruits of our work, really, that it got to fruition, and we helped do something that's never been done in the UK gas distribution network.
Brilliant. And John, could we have your question, please?
Yes, thank you. Thanks, Michael, and again, continuing the high quality presentations. I suppose from my perspective, I think it's great to see clients promote aggressive targets of reaching a net carbon zero. I suppose one of the challenges we all face as businesses is balancing the societal need and our purpose of trying to deliver net carbon zero, but also trying to manage a commercial outcome. Through the options that you chose, how did the costs stack up? And then the second part of that question is, what's the route to making your chosen solution economically viable?
Yeah, it's a great question. And it's one we've had to answer ourselves. I think there's 3 main categories you can put these sort of developing technologies into, that the boxes they have to tick as such, not just for fuel cells, but hydrogen in general. Is it needs to be as safe, if not safer than natural gas was. It needs to be as reliable, if not more reliable. I don't want to say cheaper, because I'm not sure it's ever going to be achievable, but it needs to be financially acceptable. And we showed through this trial that it is reliable, it is safe, but the financially acceptable aspect, that box isn't ticked yet, if we're being honest. We sucked up the costs for the purpose of the trial so we could get the learning, but it's not ready to be fully rolled out yet because it isn't cheap enough. That's just the facts, and that's a reality check for the hydrogen industry as a whole right now. We need to get more hydrogen out there. We need to get more fuel cells. The scale needs to go up so that the costs come down, and we've predicted that crossover point, the penny will drop hopefully around 2025. And when it does, we'll be ready, waiting to capitalize on that, because we know how fuel cells behave now on our sites. And we are going to do more to help accelerate that and make sure it gets even quicker. But that's the reality now. Hydrogen needs to get cheaper, and it's not just for fuel cells, but it's in general.
Okay, thank you.
Brilliant. Thank you very much, Michael. A great presentation and 3 good answers as well. Thank you.
Thank you. Cheers.
Next, I would like to invite Daniel, please, our Scottish regional winner, presenting on reduced depth of cover gas distribution assets.
Okay, let me just share my screen. Okay, is that visible? Can you hear me?
Yeah, that's it.
Brilliant. So, good morning, everyone. My name is Daniel Mee. I'm a senior integrity engineer at Cadent, working in the central 2 bar and below engineering team, setting the engineering framework for the organisation. And today I'm just going to give a quick overview of one aspect of the framework that I've written, alongside the underpinning justification that I've developed into how we manage reduced depth of cover on gas distribution assets, and in particular for today, medium pressure pipelines across agricultural land. So for the next 5 minutes, I'll go into a bit of background into the topic area and why it's an issue and a risk, and how we can look at historic pipe construction standards and undertake data analytics in order to identify the areas of risk and establish the level of individual risk through a quantified risk assessment that I've developed. So in October 2015, around 1,300 homes in Laceby were left without gas after a private landowner damaged a 4-inch spun iron medium pressure pipeline laid in the 1950s. The pipe was found to be operating at a depth of cover between 400 and 800 mil deep. There are a variety of reasons in which an asset could be operating at reduced depth of cover. These can range from natural erosion over time, landowner intervention, or that the pipe was laid to historic construction standards. And I've pulled together the table that you can see on the screen by spending some time in the library at Igeham House, reviewing the historic pipe construction standards and looking into the required depth of cover. And if you look at the table, what you can see is that there was no differentiation for open fields and agricultural land until 1977. And today's 1.1 metre depth of cover requirement didn't enter the industry standard until 1992. So utilising the Ordnance Survey data that's in our Esri mapping software and our pipe data, using the descriptive term of agricultural land, we can undertake geospatial queries to identify where we have pipes running across agricultural land, and using our asset data, identify where those are laid pre-1977. So to establish the level of individual risk that are posed by these assets, we've undertaken a quantified risk assessment from first principles in order to understand individual risk based on this data extract, an application of probability based on research and data that we've obtained reactively through our existing management processes that we undertake reactively. So if we take the hazardous event as the ignition of escaping gas caused by the striking of a shallow pipeline that causes the pipe to fail, we can look to determine the individual risk, which is calculated based on the frequency of incident per year, multiplied by the probability of casualty and probability of exposure. Determining the factors that influence the two probabilities along with the frequency of incident, we're able to calculate a numerical outcome of 1.48 times 10 to the minus 5, which sits you in the tolerable if as low as reasonably practicable ALARP region. It's worth noting that whilst with conservatism built into this QRA, it places the outcome into this classification, and therefore we have to, as Cadent, as an operator of these pipelines, we need to ensure that we apply relevant good practice, which we do through our reactive management, and consider then the implementation of further risk reduction measures. However, following an ALARP and cost benefit assessment that I've undertaken, implementation of further risk reduction measures in the form of a proactive identification approach based on the population of pipes that we've got at this pressure in this locations, it's grossly disproportionate relative to the risk it reduces and the benefit gained relative to the historic incidents. So to summarise, one of the large factors that contributes to reduced depth of cover is historic pipe construction standards. And whilst it's not appropriate at this time to blanket survey all of these, in respect of our net zero proposals and our desire to reconfigure, replace and repurpose parts of the network to transport hydrogen, one of the things that this work has driven as part of the validation is targeted surveys of these pipelines before considering them for repurposing, and also working with our design engineers to see if we can reconfigure the network to remove these risks from our gas supply arrangements. Thank you for listening, and I'd like to open up to questions.
That's great. Thank you very much for sharing that, Daniel. I'd like to ask Kate to open up with questions, please.
Thank you. Again, another excellent presentation. Thank you, Daniel. So from a personal perspective, what have you taken from the lessons learned, particularly in the projects that you've been involved with? What of personal sort of development, what have you taken and what sort of learning will you take going forward into your future roles?
Yeah, so from a personal perspective, although in my day-to-day role, I work quite closely with quantified risk assessments and looking at data that is often produced by consultants and third parties, this is the first time I've actually built one from first principles. So understanding that process and how the input parameters and the probabilities and the judgments that you make can have such a big impact on the outcome. So learning that entire process from first principles to actually getting an outcome and then interpreting the outcome, doing the cost benefits, that's a real big learning for me. So now when I look to review, and before we even engage with third parties who often produce these on our behalf, it's doing that bit more pre-work and a bit more understanding so that when we've got the data and we give the data to them, is the data robust enough to give us an outcome that we can draw some conclusions from, or are there too many gaps in the data that we need to iron out first before we start to put that together? So yeah, real big learning on that, developing this from first principles.
Great, thank you.
Great. John, what would your question be, please?
Yeah, thanks very much, Kyle. Again, a very good presentation, Daniel. I think the interesting question for me on this is, I think the role that the ability to access and manage and harvest data to understand an issue and then actually be able to extrapolate the extent of that issue to give you an answer. How did you find that process in terms of being able to access the information and then actually be able to put it into a format that can give you a conclusion?
Yeah, so the data sources that we use, so we use sort of I use the Ordnance Survey background data as a reference point for agricultural land. That was one element. But even then, from that, as we all know, not every piece of agricultural land is used for arable farming. Sometimes it's used for pastures, sometimes it's used for events. So then looking at, okay, well, I've got this data source from Ordnance Survey. How can I make this data source accurate? So I went on to DEFRA, looked at some of their stats on arable land in relation to agricultural, so tried to pull together as much source data as I could externally, and then internally looking at our own pipe data and our pipe network data. There's often some anomalies in some of the data sources. So what I've made prior to running the analysis, I undertook a bit of a data cleanse. So where there were obvious anomalies, such as polyethylene pipes, for example, laid before they were introduced, quite clear that's an anomaly that I had to iron out before running this analysis. So being able to identify and fix those errors, to remove some of the conservatisms, to remove some of the anomalies that would then have a big impact on the outcome. And then with regards to application of the known data sets, so the surveys that we've undertaken reactively, the data quality on that was pretty good, to be honest, because it was something that we've done in the past couple of years. So I had quite high confidence in that, so I could be confident in the conclusions that we drew from that data. So it's just about knowing which data sources have got errors, anomalies, and things like that, and actually then understanding that when you look at the equations that you pull together to see, well, if that was changed from X percentage or into a different one based on this anomaly, it then has a massive impact on the output. So understanding those influencing factors is really useful in then establishing the accuracy of the output.
Thank you.
And lastly, Dan, your question, please.
Yeah, thanks, Kyle. Dan, great presentation. Thank you for that. Data is something that's quite passionate with myself and has been. Having data is one thing, but doing something with it's the more important bit. So I just wondered if there's any examples of where you've had to take immediate action or push through data to different departments or different areas to assure the integrity of the pipelines.
Yeah, so one of the things in our reactive management approach that we take and that I've developed as part of this framework is as soon as we become aware of a potential reduced depth to cover asset, the first thing that is initiated, it comes into our engineering team. We then initiate discussions with our land representatives, customer comms teams, to get out some comms to the landowners that this pipeline runs through or could potentially run through. So we don't just look at, okay, the pipeline's shallow in this one field. We look at, okay, well, what's the potential extent of the reduced depth? So that's where we'll be looking at, okay, the pipe data in relation to the agricultural land, when it was laid, when it was constructed. And then we've also started to look at extracting leakage and damage data. So we look at the leakage data and look at what the cause of the leakage is and the cause of the failure. So if it's something like a fractured main, for example, where the pipe broke, one of the considerations that we've got there is, well, has that pipe fractured because it's shallow and it's been overloaded? So we can then start to build a bit better picture on the actual extent of the issue or potential extent of the issue. And then what we look to do is validate that suspicion through non-intrusive surveys, and then validate those non-intrusive readings through trial holes. So we then fully understand the extent of the issue, and we can then manage that and take it forward.
Brilliant, thank you.
Yeah, thanks for that last question. Thank you very much, Dan. A very good presentation again.
Thanks.
Lastly, I'd just like to invite Natalie Lamb, please. Our South East regional winner will be presenting on experimental pipe facilities and investigation of chemical-free water.
Thanks so much. Can you hear me and see my screen okay?
Yes, I can.
Perfect. So you're very fortunate today. You get to hear me and my husky voice. So that's good news for you guys. So in the UK today, we use a lot of chemicals to treat our drinking water. Tap water is absolutely fine to drink, just giving you a heads up before. I drink tap water, so it's absolutely fine. We use a lot of chemicals to treat our drinking water because of the pipe network. Can anyone guess in the chat how long our pipe network is? Are we talking days, weeks, months, years to get from the water treatment works to your kitchen tap? Jason joked in the chat, it's really nice to see that assets are older than him, but you're the spring chicken in compared to the pipe network that we have in the UK. There's actually enough pipes in the ground to go from the earth to the moon and back. Because these pipes are old, sometimes Victorian era, because there's so many of them, because they leak, it means that we have to dose chemicals to protect that water on this journey from the water treatment works to the tap. This presentation today is all about my PhD research with the University of Sheffield and these chemicals that we use to treat drinking water. So the system works. Why was I trying to shake it up a bit? Basically, the chemicals that we use have all sorts of problems, all sorts of unintended side effects, and sometimes unknown long-term availability. Chlorine, for instance, has been found to increase your risk of bladder cancers by 1 or 2% over the course of your lifetime. That's really, really low in compared to other things like living in an area where they drive cars or eating red meat, but it's a risk nonetheless. And phosphate that we dose to protect against lead pipes, of which around 25% of houses in the UK, houses built before the 1960s, have lead which is toxic within them. And phosphate forms a protective layer around the inside of these pipes. But some sources say that phosphate is going to be gone in the next 50 years. It's going to be running out because it's a mined rock reserve. So my research was all about looking at, would it be possible to have the same really good quality water, but without having any of those chemicals on this journey in the pipe network? The answer, by the way, is on average in the UK, it's about 3 days for water to travel from the water treatment works to the tap. But in some cases, it can be as many as 5 or 7 days. So that's why these chemicals at the moment are really important. So what I was investigating is, if we had the perfect pipe network, could we get rid of these chemicals? So to do this, I designed and manufactured a series of pipes, like fake pipes in shipping containers. So you walk inside the shipping container, there's a wall of pipe on the left, a wall of pipe on the right. They're identical in every way, but one of them was fed at the water treatment works from before chemicals were dosed, and the other one was fed after these chemicals were dosed. So I could directly compare between the two. I also had removable pipe sections of the wall that I could take out and then look what was growing on the wall itself, as well as just the water running through it. And what I actually found was not having these chemicals didn't really impact the water quality all that much. Megan earlier spoke to us about groundwater, which is water that's taken from deep, deep within the ground and sort of pumped up. We also have surface water, that's things like river water. My pipe rigs, I manufactured them in shipping containers so I could actually pick them up and put them on different sites. And what I actually found was if the quality of the water going into the pipe rig system was good, then it remained good whether or not these chemicals were used. Similarly, if the source water was surface in type and it was a bit worse quality going in, there was lots of microorganisms, then what I found was there were lots of microorganisms going out. The chemicals didn't really impact things all that much. So what my research shows and what my PhD work found was that, yes, I think it might be possible for us, if we had the perfect pipe system, to get rid of the chemicals that we're using today. So the reason why I was looking into this is because there are other countries out there in the world, countries like the Netherlands, who have been doing this for many, many years. But the thing is, all of their water is groundwater in source. So it's already very, very good quality water to begin with. So this is why I was doing these experiments to see if they can do it in these other countries, can we do it? It's a bit like the opposite of Megan's work, where she was taking our learnings to other countries. I was trying to take the learnings from other countries and bring it to the UK. So overall, is chemical-free water a possibility in the UK? Yes, my research shows it is. And the next steps would to be going into a place, maybe a new build area, maybe that's groundwater resource, and actually giving it a go and maybe turning off some of these chemicals. If I can find a water company that's brave enough to partner with us in this research. So my name has been Natalie Lamb. Thank you very much for listening to my research that I've done with the University of Sheffield. I'll now take any questions. Thank you.
That's brilliant. Thank you very much for that, Natalie. Great presentation again. If I could ask John to start us off with the questions, please.
Yes, Natalie, thanks very much for your presentation. Natalie, can you just give us an idea of some of the challenges you've faced during your thesis?
Yeah, so I think for me, the biggest challenge has been project management and stakeholder engagement. So going into this, I was kind of expecting to be a student, but actually I found out that I was more of a project manager. And I think I was actually kind of a micromanager because what I did was, rather than, I don't know, trusting one company to build these pipe rigs, what I instead did was I designed it myself. And then I was like, right, I would like this company to produce this individual little plastic piece. And then I'm going to go to this source and ask them for this individual little plastic piece or this metal clamp, and I'm going to do it all myself. And I think it would have been so much easier and so much better, and probably a lot cheaper as well, if I would have just outsourced everything to one company and just dealt with one contractor, because it was an awful lot of work. So I think if I was redoing this whole situation again, and I'd also get someone to help me with the design, because I'm a microbiologist by background, so I had a very clear image of what I wanted it to look like from a microbiology perspective, but not so much of a clear idea of what I wanted the pipes to look like. And the pipes themselves are very, very important when you're building a pipe rig.
Brilliant.
Thank you.
Sorry, another excellent presentation again, Natalie, thank you. So you talked a little bit about next steps, and obviously there's that, you just as I mentioned about stakeholder engagement and sort of lessons learned from there. Realistically, where would you see this sort of going, and what would your, you know, if we took away any sort of issues or problems, where would you see this sort of going, and how would you influence this taking it forward?
So I've got 3 papers that I'm going to be producing over the next 2 years based on this work. So one of them is specifically going to be on the rig design, build, manufacture, how other people can sort of replicate this system, because it didn't sort of leak or anything like that. Another one is going to be on what other countries are doing and what we're doing and how we can kind of get to where they are. And then another paper is going to be on these chemicals and what the findings of this rig facility have been. But what I really want to do is look at this phosphate. So I didn't have enough time to discuss it in detail, but we don't actually know what the impacts are of ingesting all of this phosphate. And off the back of this experimental work, I also did a big piece of like data analysis from 15 years worth of water quality data. And what I found was that the phosphate that we're dosing at the water treatment works, it's like 99.9% also at the tap. So we're consuming a lot of phosphate, and we don't really know what the implications of that are. So I'm really, really interested in taking it further by doing a bit of work about that and potentially about the concerns to do with that, because I think at the moment our solution to the lead crisis is dosing phosphate, but I think it has a lot more complications than what we realise. So I definitely think a lot more needs to be done in the phosphate sort of zone. So in terms of my work, publishing papers, also intending to sell the pipe rigs at some point. So keep an eye out for some pipe rigs on eBay. I'd love the work to continue, and I'm going to do my bit in terms of publishing and getting the word out there a bit about this phosphate it's harmful, and we need to be thinking about something else.
Thank you.
And lastly, Dan.
Yeah, morning, Natalie. Thank you for the presentation. Really interesting, insightful look into how we can potentially go chemical free. I mean, looking at the general UK supply approach, not a lot of it is ground source, although there are areas that are heavily dependent upon it. So do you think there's going to be a balance or a need to look at other types of maybe nature-based solutions that could be developed to support the chemical free network?
So in the UK, we're about 70% surface water to groundwater split, just in case anyone didn't know. And that's actually very similar to some of the other countries that I've been looking at. So the 3 countries that I've been looking at are the Netherlands, which are pretty much all groundwater, Dusseldorf in Germany, and a company in Denmark as well. And in Dusseldorf, they've actually got a really similar split to us. And what they do is they have a lot of steps to slow down the retention time of their surface water. So although it's normally sort of found on sewage treatment works, I'm actually a real big fan of like reed beds and sand filters and that kind of thing. Anything that's going to sort of increase that retention time down. Now, I'm not saying that we're going to suddenly start putting them everywhere because of the land constraints and the cost that would be. But me personally, that's the way I'd love to do it. And if we could have some sort of innovation that would reduce the land requirements of something like a reed bed or a sand filter, maybe like stacked on top of each other or something in a big column, or I don't know, I'm just spitballing here. But I think something to slow it down, because that's what they're doing in other countries. And I think if they could do it there, then we could implement some things and do it here as well. So that's what I'd really like to see. But I still think it is possible with our surface water. I just think it's more difficult.
Okay, thank you for that.
That's brilliant. Thank you for that, Natalie. And thank you for completing our final presentation of today. First of all, I just want to congratulate all 5 of you for a really incredible presentation each. I know how challenging it is for you, to deliver that whole presentation within 5 minutes, but also keep it all down to 1 slide as well. So firstly, big well done to all of you. What I'm going to do now is just invite our judges to the breakout room. In the meantime, I invite you all to have a break, but then also possibly even an opportunity to ask our 5 presenters or finalists if you do have any questions, if they don't go for a break also. So probably meeting back in about 10 minutes.
Thank you, Kyle. So yeah, I mean, John unfortunately has had to drop out, but that was an incredible set of presentations. Really well done to everybody that's competed today. And as we've also said, that was a very, very tough job for all of us judges to go through, but there is a winner. And I am absolutely delighted to announce that this year's PDN presentation competition final winner is Natalie Lamb, QCL. And obviously there we go, we can see, and in second place is Megan Macpherson from Atkins. So very well done to you guys, but absolutely well done to everybody that's presented today. Really, really great quality. Well done.
Yeah, thank you, Kate, and thank you everybody for coming on today. Natalie, very well done, and everybody that contributed today and presented. 5 really, really strong presentations, and it was very difficult on the judges' call and in the other room.
Yeah, if I just ask if you want to put your cameras on, if everyone wants to put the cameras on. If Natalie does want to say anything, she's more than welcome.
Thank you very, very much. Thank you.
I'd also like to echo those comments. It was you gave us a really tough challenge with regards to judging that. Some excellent presentations, some fabulous insights to the broadness of our industry and the the depth of which it goes with the knowledge experience and understanding that you guys have portrayed today has been absolutely superb. So well done to all of you.
Definitely.
Thank
Just
you.
before I close up the presentations, I just want to say a few thank yous, if that's possible, please. I would like to firstly thank you all to everyone that presented today. All 5 of you are brilliant, and you really do the industry proud. It's 5 really good presentations, so very well done. I'd also like to thank our judges as well, Daniel, Kate and John, for judging today and taking the time. I would also like to thank everyone that's been involved with the PDN and all the reps that have contributed to this, all the regional hosts. Well done to you all. 5 really strong candidates in the final, and appreciate all the time you put into the paper competition from synopsis all the way through. And thank you to the HQ team as well for helping us host this today.
I think just one final thank you to you, Kyle, as well, for doing an excellent job of pulling all that together and organising today's event. So well done.
Thank you very much. Okay. I'll stop sharing the screen. And I'd like to thank everyone on the call for joining us today.
Cheers, Kyle. It was really good. Kyle, thanks everyone. Congrats.
Thank you, and congratulations to all of you.
Well done.
Excellent presentations.
I'm going to clap.
Thank you. Well done.
Thank you.